Now starting. All attendees are in listen-only mode.
Hello and good afternoon or good morning or good noon to all of our listeners from all around the world today. We're gonna get started in a few seconds, just waiting until everybody hops on because it's not 12 EST yet. So just give me one more minute. So, welcome everyone to our Konstru webinar today on one of our most exciting features that we were promising you for quite some time, I know, but finally it's there, and it's fixing your models with Konstru. And we're very excited about this because actually we spend a lot of time thinking about this feature, and we also know that it's very, very useful, especially if you're using interoperability between different tools, and especially if you go from Revit, for example, to analysis platforms, because you always come across situations where your model is not properly connected and you bring it into ETABS or SAP and then your analysis fails because the connections are not right. I mean, you guys know the issues. So. And finally, we have our Fix Your Models with Konstru tool, our connectivity repair tool. I'm just going to show you quickly what you're going to learn today. And it's actually, so first of all, we developed a tool that is for connectivity analysis, that actually here in the background you see a truss with various connections, and you see that I highlighted 3 of them and labeled them with fail. This is actually a way to spot failing connections. So in this way, what you see in the background here in this truss, you see these highlighted little dots, and they show the number of connections. So this is just one way, one feature we're going to learn today, connectivity analysis. And then we're moving on to connectivity repair preview. This is actually where we generate a preview about what we're going to change, and then we have also some settings how we're going to repair the model. So we actually developed kind of a refined way how to choose which nodes to snap where, but we're going through that in detail in a second. And then finally, you can also save your connectivity repair model. So when you chose your settings you want to repair, you get a last preview, and then you can actually decide if you want to save that as a new version in Konstru. And it will actually just be committed as all the other versions in Konstru, and then you have a new version. So this is what you're going to learn today, and also for people who never use Konstru, we're of course going to start from scratch. We're just going to upload a new model. So if you never did that, you will also see how that actually works. So what I'm going to do when after logging into Konstru, you will land on this landing page with all your models, and here we see some of the webinar models we used some days ago, and I'm going to create a new model here. I'm going to call it my Revit model, for example, and I'm going to click create. Now this model is being created, and I have a new Konstru model online, and it doesn't have any versions yet because I didn't upload anything. So here there's also a video pointing you to how to upload from Revit, and that's what we're actually going to do today. So I'm jumping to Revit, and here you see I have a little model prepared. This is a little building. It has some columns, beams, braces, some walls and floors in there. And we're going to repair this model because, I mean, you know how it is in Revit. I mean, I just drew this like a few days ago, and, you know, I'm actually not really modeling perfectly clean. I mean, you know how it is. So you just use Revit snaps and then you get these connections that you think they pretty look, I mean they look fine to me, but let's see how they actually are. So I'm going to go to Konstru and I'm logged in as webinar, and here I can see my Revit model. And I'm going to select my Revit model. Now I'm going to upload my first version. I'm going to say update Konstru, and this is my first upload. I have to describe my version here. This is fine, and I'm going to say update Konstru. So now what's going to happen is Konstru, as usually, compares the two versions against each other and will tell me that we're going to add 266 elements to our model online. And we have 5 levels, we have some grid lines, and this is important for later. And we have walls, floors, columns, and 120 beams and some braces. So I'm going to say finish update. This is great. And those changes will be committed to the server. And once this is done, in a second, we can view our model online. I'm going to close all my old tabs here. And now this is rendering the model we just uploaded. So here you can see this is the model I have, and still, even online, it looks quite fine to me. But we want to investigate and use one of our new features to, first of all, analyze connectivity. So let's see what the truth is behind this model. And I'm going to go to the Repair tab up here. And what you can see now here highlighted is that you see all the nodes in wireframe mode, and you actually see their number of connections. So down here in this bar, in this colored bar, we see that this is basically the graph that we're using to display them. And here we have 1 connection on the left-hand side, and on the right-hand side 7 connections. This is actually labeled wrong. Sorry, we have to change the names here, but it means 1 connection and 7 connections. So this means the model that we see right now in here on the left-hand side has these bubbles. And this means, for example, here we have 2 connections, because this is more like this orange color, and then we have some others. Let's check over here. They're blue, and this means that there are around 6 or something-ish connections here coming in, and we can see 1, 2, 3, 4, 5, 6. Yeah. So, and then we can also see that, of course, in this situation here, we have 4 coming in, or 5, sorry. But then we have here a connection here. This is missing. So this should be a different color, this node, because it should have more connections. And we also have that situation in some other spots. And here, what is this even? We found that here there's basically 1 connection or 0 connections because it's a loose end. And here we have 2. So those 2 should go together, and it should be 3, of course. So you see I didn't work very clean, obviously. And this wasn't a very good job from my end. But that's what we're going to fix. And so what we can do here in our inspect part is we can inspect this model various ways. We can see it by a number of connections. That's what we just did right now. And then we also have distance to nearest work point. So work points are points we are considering a combination of grid lines and levels. So if we go back just to our Visualize tab, we will see that this is our model, and we see some grid lines in here. And what a work point is actually just an intersection between the grid lines and levels. So therefore we have points on each level, and it's just projected up the grid to each level. And usually we should model all our connections and members on those work points. And if they're off, then this is something we should fix. I mean, this is, for example, here the case. It's also here the case, because of course this connection should be moved upwards to the next level. So I'm going to hop back to distance to the nearest work point, and what I'm going to see here is the difference between those nodes and the nearest work point. So here we see this is red, which means this is fine because it's almost 0, or it is 0. It's on the work point. But then we have this here that is a bit purple, and it means that it's, in this case, this is the maximum. This is 412 millimeters away from the nearest work point. And this way we can easily analyze what's wrong with this model. We also can see here, those are around, we don't have a number here, but let's say around 200 something-ish millimeters away from the nearest work point. So this way we can easily spot all the odd ones out, and in the color code we see like, okay, this should all be red, right? It means like should all be on grid to grid and level intersections. So what I'm going to do now is I'm going to repair this model, and I'm going to hit the repair tab. And in the repair tab, this is where I get a preview about all the elements that might be changed. We will improve this in the coming days, and because we want to change this a bit from work flow, and we also want to show you what's actually going to change as a preview in here already. So currently we see these are all the elements that are possibly changed. That's why they're in orange. And what I'm going to do is I explained you something about work points, so that's why I'm going to say I'm going to snap my nodes to the closest work point. And we saw that earlier there was a tolerance from this point here down in this corner. There was like 400 something, and that's why I'm going to hit above with a tolerance. So I'm going to say snap everything within a radius of 500 millimeters to the closest work point. As you remember, the work point, it's described here again, is a work point is created at every grid level intersection. So, and this means that it will be snapped to that kind of point. That's what we want to do. So, I'm now going to select the 500. This is fine. And I'm going to say preview. And Konstru is going to provide a preview for me for my repaired model. And this is going to be great, because what I can see here is I can see the entire model, but I can see the repaired state. So I see that this has been snapped over there, which is nice. And now this node is yellow. Before, remember, one of them was red and the other one was kind of orange or something, and now they're yellow because these have been snapped. And we can also see here there's a little statistics about this. We have 117 nodes in total. We actually have minus 13 nodes because some of them got snapped together, so we have less nodes now, which is really nice. And then we have number of connections. We have at the smallest number of connections we have is nodes with one connection are 16. Those are loose ends at the bottom, of course. And then we have as maximum connections, we have 6 connections and 20 nodes with 6 connections. Those are the blue or purple ones. So we see all of those braces also have been repaired. So you see they're all snapped to the closest point here. So the next thing I'm going to do is going to save this because I like my result. So I'm going to hit save. And this will be stored as a new version, and I can see there is a new version being saved to my model. Now I see this is the new model, and it still looks like before, right? I mean, if you look at extruded members, it looks like the same, but let's just see what changed. And we're going to head back to change view, and here we can actually compare the current state to the first upload. And what we see here are all the braces highlighted in orange because those have been changed. And we can select one of those guys and we see the geometry has changed. And here I can also see that this member was also not connected to the closest point here in the corner, and it has been connected now. So this is great. This is exactly what I wanted to have, because now my model should be very, very clean. If I want to check again, I can always go back to the wireframe view and I will see, this is the wireframe view, this is what changed, and all those connections look pretty clean to me. So now what I can do is going back to Revit, hit Konstru again, and in Konstru I'm going to select my Revit model and I'm going to download it into Revit. And now I have a clean model. That's what I'm very happy about, because I don't have to do this manually. And you know what pain it is. If you have to do that in Revit, this is very, very painful and takes you so much time. So what I see, 5 beams have been updated and 12 braces, and I'm going to download all those changes. There's a finished download, and then there's some of the mappers that are usually popping up, and this is now done in a second. It's done, downloaded, and I can also see that here, this, for example, this member is now connected here, and I could even investigate maybe my analytical model if I go to view and just go to analytical model, activate it, and then I might see that some of those connections are much better now. Well, it's a bit dense here. That's why, I mean, that's why Konstru is actually much better, because in Konstru can explore those analytical lines much better. It's a much better view. Yeah. And this is it for the work point repair. And Jonathan today is going to show you also some of our other repair modes, because we don't have even one repair mode. We have in total 3, and they're really exciting. So I'm going to hand over to Jonathan. So give me a second. So this should work now. Jonathan?
Yes.
Yeah.
Okay, sorry about that.
Hi.
Hi. So I'm going to show you another example. I made this very, very basic floor plan just for demonstration purposes. And I highlighted 5 beams where the lines are slightly off of the plane. This happens, quite often. They're not, again, if you model something in AutoCAD or in Revit, it will be good enough for documentation, but it won't be good enough for analysis purposes. And so I'm just I used Rhino to create the model, and I'm just going to use Grasshopper now to upload this to Konstru. So I'll create a new model here in Grasshopper. I'm going to call this simple floor plan model, and then head over to Rhino and select this model and upload it. This is pretty quick. So I have 1 level in here, some grid lines and 85 beams. Okay, so now this is my model in Rhino, and again, this is very basic, and you don't see anything wrong with this. Even if I wanted to look at it from the perspective, it's very hard to see that there's anything wrong. So even if I go into wireframe mode, it's hard for me. I can sort of see it now, but only because I know that something is wrong. But it's hard to pick up these issues. So instead, we'll head over to the repair view again. And now already you can see that something sticks out. So we can see that our model has somewhere between 1 and 4 nodes. 4 nodes is what we would expect everywhere in the middle. But we can see that there's something funky here. So it's not fully connected. Actually, I just realized I didn't bring across the beams either. But so what I would want to do is now I want to connect all the nodes that are in red to the closest level. So in my repair modes, I have 3 different options. The one that Max just demonstrated was snap node to closest work point, which is a grid level intersection point. We can also take our edges, our beams, and our lines in general. Most of the time, those are beams, and we can project them to the closest level, which means that both endpoints must be within the tolerance of that closest level. So I'm going to select this repair option. I'm going to set the tolerance to be, I'm going to make it about 1 foot, and I'm going to press preview. And now you can already see all the lines that have been changed are highlighted, and you can also see that all of a sudden all of the nodes here are now purple. So this is what I wanted to see. This means that my model is now fully connected in the center, and if I press save, it creates a new version, and it made modifications compared to the previous version. There is one more repair setting. Let's talk about that one as well, which would be the trim or extend lines to the closest line. And this is, so I think the snap nodes to closest work point is the most reliable repair option if we're working with a simple grid-based model. So if we have nice grid lines and nice levels and all the elements are planar more or less, then we can use this option quite reliably. But if we are working, for example, on a stadium roof, for example, where we don't have grid lines underneath every single element, we need to start working with this option here. So this rule moves the endpoint of a line in the direction of that line to the closest neighboring line. So, for example, if I had this infill beam here and it wasn't drawn all the way, or it was overshooting a little bit, I could use this option to trim or extend this particular beam to the closest intersecting line. So the other thing that we should mention is that the order matters. So if you plan on taking multiple repair steps, what we will recommend you do is you choose only one of these options at the time. You run the repair, and if you're happy with it, you submit it and create a new version, and then you come back and run a second repair. Because I think, well, if you were to select multiple ones of these, the order of repair would be, it would execute this step to closest work point first, and then the project line to closest level second, and then trim or extend third. But I think if you look at your model and you see what's wrong with it, it may be better if you just choose the order yourselves. So you might as well create multiple versions along the way. Yeah, I think this covers probably everything. We have another 10 minutes for questions. So let's just head over to questions and answers now. The other thing, like Max said, we only just pushed this out a few days ago. This is not even a week old, and we are really looking for feedback. So somebody already mentioned that they want to see, this is really good now for CSI-based models, but for RAM, for example, this is not that great yet, because what people wanted to see in RAM is also the ability to automatically create levels and then to project those elements to the auto-created levels. So there were already some suggestions coming in, and we're really looking for more suggestions about how you think we should be repairing models for analysis and fabrication purposes.
Great, yeah, that's pretty cool. So guys, post your questions in the questions tab in your webinar panel. On the side you have this questions field. You can paste them there. That's the best place to go. Otherwise people are typing into the chat, but please type them into the questions part so we can answer them. And I already have a question. Yeah, you can go ahead.
Go ahead.
Okay, I have one question coming in. Can we also repair walls and floors with this? So, sorry, at the moment not. We are only focusing on members. So this means that we're repairing framing members, which means beams, columns, and braces. This is not implemented for walls and floors. I mean, eventually we will think about it, but it has other issues that are coming across, and I think focusing on framing members is a very good approach at the moment.
Another question. Sorry, let me just read between the lines. Oh yes. So there. Could you explain a workflow where once you do repair your model coming out of Revit, where you would not want to actually update the previous Revit model anymore with the changes?
Yeah.
So I would say for this, this is one of the main reasons why we developed Konstru this way, that every time we make a change, such as an automated repair, it actually creates a new version. So if this was our model, for example, coming from Revit, and we were happy with the Revit model as it was for documentation purposes, but not for analysis purposes, we now have a second version. And what we can do now is one thing we could do, for example, is we could simply clone this model and use it thereafter only for analysis. So I could just call this analysis model, and I could only use this for analysis purposes from here onwards. So now I have basically two separate models. My first one would be the Revit model, and my second entirely different model would be my analysis model. Or what you can do going forward is using the filters, and every time you make an update back into Revit, you would simply exclude geometric updates for beams, columns, and braces. And this way you would make sure that your Revit model does not get modified based on what Konstru just repaired, if you don't want the geometry to be modified.
That's nice. Can you quickly show the filter settings so we just see them if people haven't?
Yeah, of course. So if you go to your organization, and then this is, I guess, not my organization. Sorry, I went to the wrong one. If I go to my demo account organization, and then under settings, you click filters, and in here you can, just as a refresh, let me just show the, for example, the download to Revit filter. So I could edit this one here, and I could say every time I download beams or braces or columns, I could just uncheck the geometry checkbox. And I could make a custom filter for my project so that I no longer update those elements coming back from the repaired analysis model.
That's actually very nice. So the draftsmen, they can keep their messy model and the engineers can keep their clean one. That's really nice.
Yeah.
Yeah. We have one more question. What's happening to attached elements to our framing elements, like loads, I guess, is this referring to? So for CSI loads, that's not a problem at all. Because they are hosted by those elements, so they're attached to them. So if you have a member and you fix it in Konstru, the load is also going to move with it because it's attached to it, so it knows that they belong together. However, we don't have it in the preview, so but it's still like if you download it back to ETABS, it's not a problem. This is attached. On RAM, it's a bit different because RAM loads have their own geometry. So in this case, they won't be updated. So you would have to adjust them in that case. We could also consider a way of pulling them back, but in RAM, we don't really have the information what element they're belonging to. So that's a bit tricky. But yes, to answer you that, but for CSI, you don't have to worry much about it. Any?
So maybe we can take the time also to talk about the next steps from our end. And again, we're happy to hear about suggestions. But there was one little thing that Max already pointed out earlier, where currently we don't get a live preview of steps that are going, elements that are going to be changed. So down here, this is fixed right now. This is going to be responsive, probably starting as soon as Monday or Tuesday. When I make changes here and when I make changes to my tolerances, this should always update, and it should only highlight those elements that are in fact going to be repaired. So stay tuned. We just wanted to get this out early to start collecting feedback, and like I said, we already are hearing some suggestions about repairs. Other things that came in were cleaning up duplicate elements, and automatically creating shorter elements at intersections, like splitting them at intersections. So there are some suggestions coming in. So please keep them coming. And
Great. I think that's it.
So I think we can just wrap it up.
Yeah. So thank you, everybody. This was really great, and we hope you learned how to use it. You please remember, you can always reach out to us anyway. Like you can Skype us, call us, send us emails, and please keep in mind we have all of this documented in our documentation section. As always, just go to Konstru in the menu. You can go to documentation, and you will find all of that in there. And also in our blog post, you will find a lot of information about all the features we support and all the news and tutorials. You will find everything there. So just search around. Yeah, Jonathan is just searching for connectivity, and we will see connectivity analysis and repair, for example. So you will see some documentation in there, and we will add more, of course, and all the time. And you will also find our videos online and a lot of great information. So that's it, and reach out to us, give us feedback. We want to make this tool better, and we want to make it to fit it perfectly to your purposes. So reach out, and we will always implement your suggestions, as you know. Well then, have a good day.
Thank you very much.